Okay, we're just going to pick up here where we left off in 8.1, talking about how to solve quadratic equations by factoring. So the same rules apply for factoring that we always have. What was the number one rule of factoring that we learned? Find the GCF. Now, here's a cool thing. When you're factoring, when you're solving, normally we would just divide out that 3. But because I'm trying to solve, remember I can do whatever I want as long as I do the same thing to both sides. So it's not going to matter actually here if I factor out the 3 or if I actually divide everything by 3. Oh, divide, because what happens when I divide 0 by 3? Still 0. So I have x squared plus x minus what? 6 equals 0. Now I want to factor that. If I hadn't divided by 3, I could still factor out 3. I'll just show you what that looks like. Factor out 3. It would be the exact same thing, except for it just have those parentheses. But that 3 is not going to change your factors. In fact, that 3 is going to have no influence whatsoever on your solution. Okay? So what should we do now? That was step 1. Okay, we could do AC, or we could just factor by trial and error. Either one equals 0. Can we think of two numbers? So what are we factoring here? We're going to see what two numbers multiply to -6 and have a sum of what? Sum equal to 1. So they have to be opposite signs. Why do you say opposite signs? So can I just put x here and a plus and a minus, since we know since it's ends in a negative, it'd be opposite signs. What are the two magic numbers? Do you know? 3 and -2 would multiply to -6 and add to 1. +3, -2. Now that's factored, but it hasn't yet been solved, right? So in order to solve, what are we going to do next? Yep, and x minus 2 equals 0. So -3, -3. Notice that these ones that end in just a number, they're like the opposite signs, equals -3. Oops, put my negative. +2, x equals 2. So my solutions are -3 and 2. And then I would want to check. And for this, for the check, we're just going to plug it back in. So 3 times -3 squared plus 3 times 3 minus 18 equals 0. And let's just trust me on this, 0 equals 0. But I just want to show you that you're going to be plugging it in. We have a lot more types of problems to do. Oops, that's a +2 plus 3 times 2. Does anybody need me to go through the whole check with you on how we would solve that? And also, we could use our calculator right now at this moment too to check it. It's because it's kind of time-consuming here. Okay, for the next one, is it written in standard form? Let's ask ourselves that first. Standard form? No? Why not? Is it set equal to 0? Yes. It's missing the B, right? It has A, it has C. Well, how many B's do we have? What's the coefficient of B? It would be, or B, actually, sorry, the coefficient of Y. 0Y, so B is equal to 0. That doesn't matter because we just need to factor. It's just, maybe that's why it didn't look like it was in standard form right away, because you were used to seeing a trinomial, right? But if it's not factored, what should we do next? Factor it, right? What would be the factors here? Does anybody recognize this special form? +5 and -5. What do we call this one? Yes, difference of two squares, dots. Okay, since the signs are opposite, can you tell right away what y is going to be? What are the solutions? and negative 5, right? Positive 5 came from here, because positive 5 minus 0. Now our check is a little bit simpler on this one. So 5 squared minus 25, is it equal to 0? Yes, 25 minus 25 equals 0. 0 equals 0. For negative 5, again, it's really, really important whenever your number is negative that you put it in parentheses, okay? Minus 25 equals 0, because what happens when you square negative 5? Positive, yes. So that's why you end up getting 0 here. 0 equals 0, right? Okay, so for this one looks all kind of messed up. Is it in standard form? Yes. Yes. Oh, sorry. Yes, this is stating the solution. Solution set notation. No, I just usually put the smaller number first. I don't think it should matter though. Okay, so what do you want to do with this one? We have to put it into what kind of form? Into standard form. Now, here's what I'm going to tell you. Whenever x squared is positive, I think you should leave it alone. If it's negative, we're going to want to make it positive because we never ever factor with x squared being negative, right? So what would I have to do to put this? Step 1 is going to be put it in standard form. How am I going to put it in standard form? What do we need to do? So I would leave the x squared alone only because it's positive. So let's go ahead and distribute here first. So we're going to get x squared equals 8x minus 2. The reason why we want x squared to be positive is because we're going to... Oh, 16! You guys, I made the classic blunder. I'm so glad I have 30 eyes watching me, approximately. 16. Good call. Oh my gosh, I cannot believe I did that. Okay, now what I'm going to say next is let's always try to shoot for, we want x squared. We want a to be positive, if possible, right? So how can I get these other things? How can I get 0 on one side? Subtract 8x, right, from both sides. And what would I do with the negative 16? Yeah, I'm sorry, I'm just stacking them up because I'm running out of space. Plus 16 because I wrote all those notes there. Okay, so now what's the new equation? X squared minus 8x plus 16 equals 0. So that, my friends, is standard form. We had to do all of that to get ready to do what? What's the next step going to be? Is to factor. Well, is there a GCF? That's always a good thing to look for. You always want to look and see, is there a GCF? But if there isn't a GCF, then we can proceed to factor, okay? So let's put our factor pairs here. Can anyone tell me two numbers that multiply to 16 and add to negative 8? What is it? Negative 4. X minus 4 times x minus 4. Does everybody agree on that? Those factors. So what would x have to equal in order to give us 0? Equals 0 is, do I have to write this other one, x minus 4 equals 0? Do I have to do both of them? It's the same. X equals 4, same thing here. X equals 4 because you guys caught my mistake. So here I really only need to put a 4 in the set notation. Still should do my check, okay? And I always suggest you check in the original because if I hadn't kept that mistake, that distribution error, I would have gotten the wrong number, okay? You had a question? Oh, you could write this as x minus 4 squared. Is that what you mean? You could, absolutely. So it'd be the same thing as x minus 4 squared equals 0. You can write it either way. In the set notation, no, because the answer itself is 4. Oh, yes, the answer is not 4 times 4. It's just 4. It's the same 4, right? Okay, so for the check, I'm going to plug in 4 here. And I'll have 4 squared equals 8 times 4 minus 2. And I don't know if that's correct, so I'm putting a question mark there. This is what my check is. I'll switch colors now. Okay, so 16 equals 8 times 2, right? 16 equals 16. You had a question? Right. So they're both 4. Right. So what ends up happening is for this one, if we went back to our parabola example, you have a parabola, which is the reason why your problem is quadratic, but you have a parabola that ends up sitting at just one spot. So even though you get 4 twice, it's the same exact 4. You see what I'm saying? So you just got the same. I mean, it was as if I got the same answer over and over and over again. That's the same. Okay, but it's just twice. Okay. Yes. Uh-huh.